Hey guys, welcome back to the third video of the Numpy Tutorials for Beginners series. In this video, we'll be covering simple operations in Numpy. So over here, I've defined two Numpy arrays, A and B, which are 1, 2, 3, 4, 5, 6, 7, 8 respectively, and these two arrays are two-dimensional. The first function is np.add, which performs element-wise addition. So if we run the code, we get 6, 8, 10, 12. So this does it by adding each element together. So 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12, which is what we get over here. If you want to perform element-wise subtraction, we can replace this with subtract, and you see that we get the differences, and all the differences are minus 4. Now let's replace this with a plus b, which is exactly the same as np.add. You can see that we get the same result. And if you use the minus sign, we get the differences. So if you use the mathematical operator in Python, the syntax will be a lot simpler. So yeah, it's up to whatever you want to do. Next, we'll talk about A times B. So if you've done linear algebra before, you might think that this is performing matrix multiplication, where we take the dot product of the row of the first array and the column of the second array, and then you get the elements for the final array. However, this is not the case because this actually performs element-wise multiplication. So you see here that we actually multiply 5 and 1, which is 5, 6 times 2 is 12, 3 times 7 is 21, and 4 times 8 is 32. So this is element-wise multiplication. We also can do element-wise division, and we see that we divide 1 with 5, which is 0.2. 2 divided by 6 is 1/3, which is 0.333, and so on. So next, let's talk about the dot product. So over here, I've made two more arrays, C and D. So over here, what the dot product does is that it basically multiplies each element with each other and adds them together. All right, and let me print out C. So over here, what it does is that it multiplies each element. So 0 times 9 is 0, 1 times 10 is 10, 2 times 11 is 22, and so on. And it takes all the products and adds them together. So that's how dot product works. If we apply dot product to a two-dimensional array, we get this matrix, which is the inner product of these two arrays, which I'll not be going through in this video because it's a little too advanced. So next, I'll talk about matrix multiplication. So this is probably what you have done in linear algebra before. So what we can do is that we can use the np matmul function. So here we basically take the dot product of a row and a column, and then we take the dot product and we put it as each element. And this is, you probably have already covered this in a linear algebra course, and we can also replace this statement with A at B to make the syntax a little more concise, and we'll get the same result. So now let me talk about transposing a matrix. So to do that, we can simply use T, and that's it. So here we get the transposed matrix. So basically what happens in the transposed matrix is that we take a mirror image of along the diagonal. So if we draw a line through the diagonal, then we basically switch it around, switch the elements around. So over here, 2 and 3 switch over, and So over here I've written another array 1 2 3 4 5 6. So this is not a square matrix anymore, and basically I switch it over, so 2 and 4 swap places and 3 and 6 then move down. Alright, so basically I transpose the matrix. So now let me talk about functions in Numpy. The first function we'll go through is np.abs, which stands for absolute. So what it does is that it takes the absolute value of each element. So here what we do is that even though we have negative values, what ABS does is that it takes the absolute values, so all the negative signs are removed and we'll end up with positive values in our final answer. Next, let's take square root. Oh, we cannot take square root of negative values. So let me remove the negative values. So here we get the squared values of each element in matrix A. So that's how NumPy square root works. And finally, let's try sine. So what it does, it basically takes the sine values of each element, and this is what we get. Alright, so this is how NumPy functions work, and you can check out the NumPy documentation for more information. Finally, let's talk about np.sum. So if you take np.sum a, what it does, it basically takes all the elements and adds it together, which is 21. Now let's say we want to take the sum along each column. So we can do this by typing axis 0. So here we get 5, 7 and 9 because we add 1 with 4, which is 5, 2 and 5, which is 7, 3 and 6, which is 9. Alright, so we basically take the sum along each column. To make it a little clearer, again, 1 plus 4, 5, 2 plus 5 is 7, 3 plus 6 is 9. That's how np.sum works. Let's change the axis to 1. This time it will take the sum along each row. So 1 plus 2 plus 3 is 6, 4 plus 5 plus 6 is 15. So yeah, that's how the numpy.sum function works. And yeah, that's it for this video. If you liked this video, then please consider liking and subscribing to this channel, and I'll see you in the next video. Thanks for watching.